All right, so let's review for the week. For this first part, we're going to convert each decimal degree measured into degrees, minutes, or seconds. And each measurement that is in degrees, minutes, seconds, we're going to convert into decimal degrees. All right, so let's take a look at number 21. It is given to us in degrees, minutes, seconds. Let me grab my calculator for that. What I'm going to do, I'm going to look at the smallest measurement, 39. So let me go 39 divided by 60. That gives me a decimal. I'm going to add 1. And the reason why I'm adding 1 because the next measurement is 1. So it gives me a press enter. Divide this by 60 again. That gives me a decimal. Now here, let me add 349. And the 349, because that's the degrees, 349 equals. My answer is 349.0275. So 349.0275. That's it. You guys are like, how did we do this again? First I did 39 divided by 60. Remember, we did 39 divided by 60. 39 divided by 60 gave me 0.65 plus 1. And the 1, I got it from here, divided by 60. And that gave me 0.0275 plus 349. And that's how I got it. All right, so now for this other one, let's take a look at number 23. Because that's given in the same measurement, the same way. Given to me as minutes, degrees, minutes, seconds. So let me grab my calculator here. I'm going to start with the smallest measurement, which is 27. 27 divided by 60 gives me a decimal, plus 54. And then this number, let's divide it by 60. Gives me a decimal, plus 145. My answer is 145.9075. That's simple. All right, now for what about when the measurement is given to me as a decimal? First of all, I'm going to start with 130 degrees. Let me move my calculator here. Okay, 130 degrees. That's what I get from 30 degrees. So now I'm just going to look at the decimal part. 0.635. I'm going to multiply this by 60. Notice in this case I'm multiplying. I get 38.1. So I'm just going to use the decimal, the number before the decimal. 38. Okay, so let me take away 38 because I already wrote it down. That gives me a decimal. Let me multiply this by 60. Gives me 6. So I have 130 degrees, 38 minutes, 6 seconds. Take a look at number 24. I have 30 degrees. Let me just take a look at the decimal part. 0.745. I'm going to multiply this by 60. So that gives me, I'm looking at the number before the decimal, 44. So that gives me 44 minutes. So let me take away 44 because I already wrote it. I'm just looking at the decimal part, 0.7. I'm going to multiply this by 60. Multiply by 60. So that gives me 42 seconds. So I have 30 degrees, 44 minutes, 42 seconds. That's not bad. All right, let's take a look at Tuesday stuff. On Tuesday, we saw the angle sum or the difference identity. I gave you guys some formulas. Gave you guys these formulas. Use the first one if you're going to be adding. You're adding two angles in sine. Use this one if you're subtracting using sine. If you're adding angles using cosine. If you're subtracting angles using cosine. Now the angles, I also gave you guys what we call the unit circle. On Tuesday, I talked about how to come out with these numbers. And I said on each degrees, there's an x and a y value. My first one is my cosine, and my y value is my sine. So when I say cosine of 30 degrees, I'm just going to change it to radical 3 over 2. When I say sine of 30 degrees, that is 1/2. So this is how to use this. You guys have the unit circle. So now let's take a look at our work. Okay. Sine of 165. I'm thinking two numbers that either added or subtracted equals 165. From our rules, we have 120 and 45. Our angles 120 and 45. So I'm just going to go sine of 120 plus 45. So I'm using the sine of A plus B. According to our formula, we have sine of 120 times cosine of 45 plus cosine of 120 times sine of 45. You notice I'm using 120 is my A, 45 is my B, according to our formula. And when I say according to my formula, I'm looking at this one. All right, sine of 120. I'm using the numbers from my unit circle. Sine of 120 is radical 3 over 2. Cosine of 45 is radical 2 over 2. Plus, cosine of 120 is negative 1/2. Sine of 45 is radical 2 over 2. So I have radical 6 over 4 minus, I'm calling it minus because of that minus sign, minus radical 2 over 4. That is basically radical 6 minus radical 2 all over 4. The way I'm going to type this is a big parenthesis on top. Radical 6 minus radical 2 all over 4. Now let's take a look at question number 26. Cosine of negative 15. So I'm doing cosine. All right, so two numbers that I add or subtract, in this case subtract, that equals negative 15. I'm going to go 30 minus 45. According to our formula, I'm using the formula cosine of A minus B. According to our formula, it gives us cosine of 30 times cosine of 45 plus sine of 30 times sine of 45. According to our unit circle, cosine of 30 is radical 3 over 2. Cosine of 45 is radical 2 over 2. Plus sine of 30 is 1/2. Sine of 45 is radical 2 over 2. So I have radical 6 over 4 plus radical 2 over 4, which is radical 6 plus radical 2 all over 4. The way I type this, a big parenthesis for the top, radical 6 plus radical 2 all over 4. Let's take a look at number 27. Thinking two numbers that are added or subtracted equals 165, I'm going to do cosine of 120 plus 45. According to a formula, because I'm going to use cosine of a plus b, according to a formula, we have cosine of 120 times cosine of 45 minus sine of 120 times sine of 45. Now, according to a unit circle, cosine of 120 is negative 1/2. Cosine of 45 is radical 2 over 2 minus sine of 120 is radical 3 over 2. Sine of 45 is radical 2 over 2. So I have negative radical 2 over 4 minus radical 6 over 4, better known as negative radical 2 minus radical 6 all over 4. That way I'm going to type this will be a big parentheses for the top. A negative radical 2 minus radical 6 all over 4. To get sine of 75, I'm going to do sine of 45 plus 30. According to a formula, I'm looking at sine of a plus b. We have sine of 45 times cosine of 30 plus cosine of 45 sine of 30. Now, according to a unit circle, sine of 45 is radical 2 over 2. Cosine of 30 is radical 3 over 2. Plus, cosine of 45 is radical 2 over 2. Sine of 30 is 1/2. So I have radical 6 over 4 plus radical 2 over 4. That gives me radical 6 plus radical 2 all over 4. The way I type this is a big parentheses on top. Radical 6 plus radical 2 all over 4. Little lengthy, but not too difficult. Let's take a look at the last two questions. Let me give myself some room first. Cosine of 195. Thinking two numbers that I add or subtract equals 195 from what I have, I'm going to go 150 plus 45. Cosine of 150 plus 45. Once again, these are angles that I find on the unit circle. According to the formula of cosine of a plus b, I have cosine of 150 times cosine of 45 minus sine of 150 times sine of 45. According to a unit circle, cosine of 150 is negative radical 3 over 2. Cosine of 45 is radical 2 over 2. Sine of 150 is 1/2. Sine of 45 is radical 2 over 2. So I have negative radical 6 over 4 minus radical 2 over 4. So that is basically negative radical 6 minus radical 2 all over 4. That way I'm going to type this, a big parentheses for the top, a negative radical 6 minus radical 2 all over 4. Lastly, let me do cosine of 75. I'm going to do this as cosine of 45 plus 30. According to a rule of cosine of A plus B, I get cosine of 45 times cosine of 30 minus sine of 45 times sine of 30. According to a unit circle, cosine of 45 is radical 2 over 2. Cosine of 30 is radical 3 over 2. Minus radical 2 over 2, and then sine of 30 is 1/2. All right, so I have radical 6 over 4 minus radical 2 over 4. So that simplifies to radical 6 minus radical 2 all over 4. That way I'm going to type this, a big parentheses for the top, radical 6 minus radical 2 all over 4. Little lengthy, but not too difficult. That was Tuesday. Now on Wednesday, let's move on to Wednesday stuff. We saw the double angle and the half angle identities. Now for these, I know I gave you guys some formulas. For the double angle formulas, the half angle formulas, gave you guys those formulas. So that's what we're going to use. So let's take a look. Cosine of 2 theta. For this, I'm going to use, I have choices. I'm going to use cosine squared of theta minus sine squared of theta. That's from the formulas that I gave you guys. All right. Then I see theta is in between 180 and 270. So if I was to look at my quadrant on my x and my y axis, 180 and 270, that's the third quadrant. So I'm going to make my x and my y axis, but I'm going to make the third quadrant a little bit bigger. I'm going to say theta, it's somewhere about here. Remember, I have to create a triangle where my 90-degree angle is on the x-axis. All right, so let's see what I'm given. Cosine, I know cosine is adjacent over hypotenuse. So in the negative sign, I'm going to give it to the radical. So I'm going to say the adjacent is negative radical 31. The hypotenuse is 16th. I don't know how big is this opposite side. I don't know how big is this side. I do need the opposite since I'm going to be dealing with sine. Okay, so let me solve for sine, for x. I have that x squared plus the negative radical 31 squared is equal to 16 squared. So I have that x squared plus 31. Now 16 times 16, that's 256. Let me take away 31. So I have that x squared is equal to 225. So that means that x is the square root of 225, which is better known as 15th. I needed to find this side because I'm dealing with sine. All right, cosine. I know cosine is adjacent over hypotenuse. So I have that negative radical 31 over 16th all squared. That's what that square means. Minus, I know sine is opposite over hypotenuse. 15 over 16th all squared. Right, that's what that square means. All right, so from the first fraction, negative 31, negative radical 31 times negative radical 31, I have 31 over 256 minus 225 over 256. That gives me a negative 194 over 256. Simplify the fraction if possible. I'm going to divide each number by 2. So I get negative 97th over 128. The way I'm going to type it will be negative 97th over 128. Simplify your fraction if possible. Let's take a look at number 32. Sine of 2 theta. I know for sine of 2 theta, I gave you guys the formula 2 times sine of theta times cosine of theta. I look at theta and it says it's in between 0 and 90. That's the first quadrant. So I'm going to make my x and my y axis, making the first quadrant a little bit bigger. I have to create a triangle where the 90 degrees is on the x axis, so that's theta. I'm given that the cosine, and I know cosine is adjacent over hypotenuse, so the adjacent is 5 radical 34. The hypotenuse is 34. Since I'm going to be dealing with sine, I need the opposite. So let me solve for the opposite. I have that 5 radical 34 squared plus x squared equals 34 squared. I know if I was to square the 5 times 5 is 25. If I was to square the radical, I get 34. However, 25 times 34, 25 times 34 is 850. So I have 850 plus x squared is equal to 1,156. Let me subtract 850. I get that x squared is equal to 306. So x is equal to the square root of 306. I check on my calculator, that's a decimal. However, I can split 306 as 9 times 34. And the reason why, because 9 is a perfect square root. So this is 3 radical 34. Okay, so this is 3 radical 34. Okay, so ready to use my formula. I have a 2 first. So matter of fact, I'm going to write it as a fraction. 2 over 1. Sine of theta. I know sine is opposite over hypotenuse. So 3 radical 34 over 34. Cosine is 5 radical 34 over 34. All right, so on the top, let's take a look at the big numbers. 2 times 3 times 5. That's 30. Times 34. And my 34, because I have radical 34 times radical 34, is just 34. I'm not even going to worry about how much is 30 times 34. Let me just leave it at that. At the bottom, I'm ignoring the 1 because it's all multiplication. I have 34 times 34. Cancel those 34s. So my answer is 30 over 34. Obviously, simplify the fraction if possible. 30 over 34 can be simplified as 15 over 17. The way you will type it will be 15 over 17. Not too difficult. And the double angles are actually harder than the half angles. So let's take a look at another double angle, tangent of 2 theta. For this one, I said we're going to go 2 times tangent of theta over 1 minus tangent squared of theta. For tangent, I need opposite and adjacent. All right, so let's take a look. My theta is in between 90 and 180. That is the second quadrant. I'm going to put my theta there. I have to make a 90-degree angles where the 90 degrees is on the x-axis. So here's theta. I have that the opposite Oh no, adjacent, because remember cosine is adjacent over hypotenuse. I have the adjacent is negative 12, because that's where I use the negative on the adjacent. The hypotenuse is 13. Since I'm using tangent, I do need the opposite. So I'm going to say it's x for right now. So let me call this x squared plus negative 12 squared is equal to 13 squared. I have that x squared plus 144 equals 169. Let me subtract 144. X squared is 25. So x must be the square root of 25, which is better known as 5. All right, so let's take a look. On the top, I have 2 times tangent of theta. So matter of fact, my 2, let me write it as a fraction. 2 over 1. Tangent of theta I know is opposite over adjacent. So 5 over negative 12. Over, at the bottom I have 1 minus tangent squared of theta. So 5 over negative 12 squared. All right, let me deal with the fraction on the top. I have a 10 over negative 12. I know we can simplify, but let me just leave it at that for right now. At the bottom, I have 1 minus 25 over 144. The 1 before the minus, I wanted to write it as a fraction. I'm going to write this as 144 over 144. That's 1, but I want to have common denominators. So, all right, let's see. On the top, I have 10 over negative 12, right? Not doing anything on the top yet. At the bottom, 144 minus 25. That is 119 over 144. So I have a fraction divided by a fraction. So let's do this. 10 over negative 12 times. I'm going to do the reciprocal of the second fraction. 144 over 119. Let me simplify in this case. The 12 with the 144, let me divide each by 12. So this is 1, this is 12. So my answer, I have a negative sign. And on the top, I have 120 over 119. The way I will type this will be negative 120 over 119. Now, half angles are a little bit easier. For sine of theta over 2, I said we're going to be dealing with the positive and negative. I said a big square root of 1 minus cosine of theta all over 2. If you notice, I need cosine of theta. I do know what cosine of theta is. Let me deal with that fraction. I'll deal with the square root at the end. So I have 1 minus 4 over 5 all over 2. So the way I'm going to do this, I'm just going to go on the top. Let me call that 5 over 5. So I have 1 over 5 divided by 2. Is it okay if I just call it 2 over 1? That way I have a fraction over a fraction. So I have 1 over 5 times 1/2, because remember I changed it to times. I do the reciprocal of the second fraction. So I get 1 over 10. Remember I said I was going to deal with the fraction first, and then I was going to deal with the square root? Because it's the square root of everything, I can basically do a square root. A square root of a fraction is a fraction of 2 square roots. Now, square root of 1 is 1. Square root of 10 is square root of 10. Let me write that over here. I have 1 over radical 10. Cannot have radicals at the bottom. So let me multiply top and bottom by the radical that I have at the bottom. So I have radical 10. Radical 10 times radical 10 is just 10. Now, how you will type this? Radical 10 over 10. Looking at question number 35. Cosine of theta over 2. For this, I gave you guys the formula, plus or minus the square root of 1 plus cosine of theta over 2. Seems like I need the cosine of theta, and I already know what cosine of theta is. Let me deal with the fraction first, and then I'll deal with the square root. So I have a fraction. On the top, I have 1 plus a negative 4 over 21 over 2. So in fact, let me write that as 2 over 1. My 1 at the beginning, let me call that 21 over 21. So I have 17 over 21 over 2 over 1. That is basically 17 over 21 times 1/2. So that gives me 17 times 42. Now I said I'll deal with the fraction and then I'll deal with the square roots. I cannot have radicals at the bottom, so let me multiply top and bottom by 42, by radical 42 in this case. On the top, 17 times 42 is 714th. So I have radical 714th over 42. That way you will type this will be radical 714th over 42. Lastly, let's take a look at tangent of theta over 2. As said, for this, we're going to do plus or minus the big square root of 1 minus cosine of theta over 1 plus cosine of theta. That's the formula I gave you guys. We have what cosine of theta is, so I'm ready to move on. Let me look at the fraction first. I have 1 minus 4 over 5 over 1 plus 4 over 5. Each of my 1's, I'm going to change it as a 5 over 5. Just want to have fractions with the common denominators. Right? 5 divided by 5 is 1. So 5 over 5 is 1. So on my top fraction, I have 1 over 5. At the bottom fraction, I have 9 over 5. So I'm just going to go 1 over 5 times 5 over 9. These 5's, become 1. So on the top, I have 1 over 9. Now let me deal with the square roots. And I get 1 over 3. You will type this as 1 over